Alright, so today we're looking at the scalar multiplication involving vectors. So the learning intention is to gain the knowledge of a scalar and its application or effect on vectors. So students will be successful if they can correctly describe what a scalar is, recognize the mathematical symbol for a scalar, and that's the Greek symbol lambda, identify parallel vectors by their scalar, and convert vectors into unit vectors. Okay. So, important note to know from our NESA glossary, a scalar is a quantity with magnitude but no direction. Okay, so it's a length, but it has no direction. Yeah. So when we multiply a vector A by a scalar lambda, it's going to give us a vector in the same direction, so we're going to go the same way, but it's going to be lambda times the magnitude of A. So it's going to be lambda times the length of A. So I've drawn A as the unit vector in the sense of it's 1 unit in length, and let's say it's going up 45 degrees to the east. Okay. Well, if I want to double it, I'm going to get lambda A, and it's actually 2A. All I'm doing is multiplying its length. The direction is still the same way, but it's now twice as long. So it's 2A. If I double that again, I get 4A. Now, scalars can go from 0 to infinity. Obviously, I can have a fraction. I can shorten that vector by half and have half of vector A. I can also go negative, and if it's a negative, that changes the direction. So all of these are going to the east. Now all of a sudden, northeast, all of these now sudden, it's going to the southeast. So this is a vector of negative 3A. So it's 3 times longer, but it's going in the opposite direction. Okay, so here let's do some examples. I've done this on the page. We want to find a scale of lambda that reduces a vector with a magnitude of 4 to a unit vector. So I have this kind of thing. I have a vector with 4 units, and what I want to reduce it is into that vector. So since my magnitude, so mod 4, that's the magnitude of 4, where mod is the magnitude of v, so that's how we describe the length of this vector. Yeah. Well, my unit vector is going to be a quarter of that. A quarter of that's going to equal 1. Or we could have had lambda v equals 4, and we would basically want to divide by 4 to get, or 4 mod equals 1. And we'll obviously divide by 4 to get the lambda is equal to a quarter. Yeah, so the scalar factor is the reciprocal. Okay. Obviously, if I had that type of vector, and I obviously wanted it to get to a unit vector, I'll multiply lambda by 2 to get to the unit vector. Yeah. Okay. So the unit vector, this is an important kind of formula. We see it quite often. So the unit vector parallel to the vector v. Yeah, so we've got a vector v, and we want to find the unit vector that's parallel to that. So I want to find the unit vector that's parallel, is the vector v multiplied by 1 over the magnitude. Yeah, and that's going to give you the vector divided by the magnitude. Okay, so we have vector A. It has a magnitude of 4 in a direction of 23 degrees. Vector B is parallel. Yep, so it's got the same direction, but it's a different length, and it has a magnitude of 10. Okay, we want to find the scalar of lambda given that b equals lambda a. Okay, so we know that vector b has so the magnitude of b is going to be lambda of the magnitude of a. So b was 10 and a was 4. Okay, so what we're going to do is divide it by 4, so we're going to get 10 over 4. So really, lambda in this situation, the change is 2.5. Yeah, I go from A, I times vector A by 2.5 to get B. All right, now I want to go the other way. I want to get I want A represented in a lambda of B. Yeah, so my mod of A, lambda mod of B. So we know A is 4. We have lambda. We know the B is 10. Okay, so the lambda that I want is 4/10, which is 2/5. Okay, so A is 2/5 of B. Okay, and that's what a scalar is. Okay, so a scalar is its magnitude of the vector based on the unit vector. Okay.